Now we are going to go over radix sort. So radix sort is actually like counting sort, and the reason is because it also uses a non-comparison algorithm where it doesn't compare two numbers, it sorts using a different approach. So it doesn't, again, compare two numbers to sort our array or given input. So how does it sort the input? It sorts elements by first grouping the individual digits of the same place value. Let's say that we have an array with a bunch of numbers. So what it's going to do is it's going to look at the ones digits first, and then it's going to sort based on that value, and then it's going to look at the tens digit, sort based on those value, and finally it's going to look at the hundreds digit and get our final sorted result. Then sort the elements according to their increasing, decreasing order. So let's go with increasing. First sort based on the units place, which is this, tens place, this, and so on and so forth. So 100. Now, our numbers can be in a different base. What does that mean? It means that, for example, let's say we have our number as 123. And if you were to give a base of 10, that will be represented by 123, right? And it's going to have 3 digits. If we were to convert 123 into binary number, it will be represented by this, and then it would have 8 digits. So depending on the radix that we use, you might get better time, but worse space, or we can have the opposite case where we have worse time and better space. Now let's go over our time complexity really briefly. This is time complexity based on radix sort that uses a counting sort, and we are of course going to try to implement a solution that doesn't use counting sort, but we'll do both. O of D comes from the number of digits. So if we had the number 123, we would have a digit of 3 because we have 1, 2, 3 digits. And O of N is of course the number of elements in our array, and O of B is the base where it's the range of numbers. So if we're to use the decimal system, it has values from 0 to 9, right? And it's going to have 10 values, whereas binary is going to have 2 values and the range is only 0 to 1 because binary numbers is only represented in zeros and ones, right? Now, O of N plus B, this comes from counting sort. And if you remember, counting sort has something like K, N plus K. We just changed our base to B, where K is the range of the numbers in our array. So maximum was 123 and minimum here is 5. So range would be 123 minus 5. That was our range. But for radix sort, where we use decimal, it's only going to be 10. And time complexity, they're all going to be the same. And space complexity comes from counting sort, where K represents the number of possible values, and we change this to B, where it's base of the numbers. So radix sort will have time complexity better than O and log n. If we use a different radix like 32 bits and 64-bit numbers, then it can compare to something like O of n time. But the downside is that the space is going to be huge. Now that's it for radix sort. And again, we are going to implement 2 different concept solutions where we don't use counting sort, and solution where we do use counting sort. And solution that does require counting sort is gonna be, I think, a little bit more hard to implement, but we'll do both. If you guys find this helpful, make sure you guys like and subscribe. Thanks. Now let's see how radix sort work step by step. So we have our array and we have a bunch of numbers, and I just wrote the numbers from order from beginning to the end, and I added 0 for the numbers that don't have digits of 3. So 5 became 005 and 26 became 026. What we do is, in the first step, we are going to look at the ones digit. And what are the ones digits? Ones digits are these. And we are going to sort based on those. So we go through the array and we have 2 zeros. So 0, 0, 0, 0, 0, 0. And we are going to sort the rest. And you can see that we sorted our array or numbers based on the ones digit, which is represented by this. And if you look again, they're all sorted, right? 0 through 6. Then what we do is we look at the tens digit, and we are going to get something like, this is the result we get. And as you can see, our tens digit, it's sorted from 0 to 8. Now finally, we are going to look at the hundreds digit. As you can see, we are actually sorting the numbers a little bit each time. So first one is going to be 0, 0. And now you can see that our hundredths digit is now sorted. And this is actually it for radix sort. We look at the places, sort by order each time. So concept itself for radix sort is really straightforward. Coding it is a little bit harder, but we will get to that. And now let's get to our solutions. Now let's go over our first solution, and for our first solution we are going to create two buckets to handle positives and negatives, and later we are of course going to code our solution where we just use one bucket, but for demonstrative purposes, I think having two buckets illustrates this problem really well, especially when we are coding our first solution. So now let's go over our pseudocode. First thing you want to do is you want to create a function that takes two parameters. First one is going to be array, and next one is going to be radix. And we gave a default value of 10 because I want to just use the decimal number system. And of course, you can use different ones later, but let's stick with decimal number system because that's easier to understand. And second one is going to be, we want to create a variable to store the maximum number of significant digits. So of course you have to consider the case when the negative number has the most number of digits. And if you were to look at our array, we have negative 310, and obviously this one has 3 significant digits, right? Whereas the other ones just have 1. So make sure to just not to look for the maximum number, because it might be the case that we have a negative number that has more significant digits. Next, we want to iterate until the place that we are looking at, so current digit that we're looking at, is less than or equal to maximum number of significant digits. And next, create positive and negative buckets and fill it up with just empty arrays. Next, we want to iterate through all the elements in our array, and you want to create a variable to get the bucket index of the current element that we are looking at. So if we were to look at the ones digit at first, we want to return 0, 3, 2, 2, 1, 1, 0, 0. And if we were to look at the tens place, it will be 1, 0, 0 for the rest. And when we look at the hundreds, we want to just return that 3 because we want to put it in index at 3. If that is done, we want to check. If the current value is negative, we want to push that number into the negative bucket. And if it's the other case, we want to move it to the positive bucket. And finally, when we are done with one iteration, so when we are done with the ones place, what we want to do is we want to unwrap all the elements in the positive and negative buckets and overwrite that to our input array, and just keep continuing this loop until place is less than or equal to max. And finally, we want to return our array. So this is our pseudocode. Give it a go if you can, and if you can't, always just come back to it later. Now let's get to our solution. First thing I want to do is I want to get the maximum number of significant digits. So I'm just going to call it max. And what we do here is we're converting our number into a positive. Well, we're using spread operator first, and then we're finding the maximum number, and then we convert it to a string and get the length of that number. So this one should give us a 3. Next, I want to create a variable that's going to track the current place, and I'm going to set this equal to 1. And while my place is less than max, I want to iterate, and we are incrementing place after, so this evaluates to 0 for the first one. So if I were to just console log place, we don't start with -1, we start with 0. Now I want to create my buckets, so let's create positive bucket, and we are going to initialize this with the length of radix, and we are going to fill it up with empty arrays. So this is going to be filled up with empty arrays, and it's going to have a length of radix, which is going to be 10, and that's our digits, right? 0 through 9, so we have 10 digits. And now I need my negative bucket. What we'll do is we'll use a different method to create our array. So we're going to give a length of radix. We'll do map and fill it up with empty arrays here too. And if I were to just console log this, so positive bucket, you can see that we just have bucket with 10 buckets, and it's going to be the same exact thing for negative bucket. Let's just return our array here. Okay, that looks good. And now we need to iterate through our array, and let's just use our for loop. Now we need to return the digit of the current place that we are looking at, and I think this is actually the hardest part of this solution. So let's name our variable bucket index, and what we'll do is we'll round down and we want to convert our number to a positive number, and we want to divide that number by math.power, pass in our radix as our base, and place as our exponent. And we are going to mod it by our radix. Now what does this do? What we're doing is we're creating or converting our number into a positive, and we're dividing it by the power, and our radix is 10, right? So that's our base. So base 10 to the 0 is going to give us 1. When you have anything to the power of 0, that's going to result in 1. So that number divided by our base or our power or the current digit that we're looking at, and if we were to mod that by our radix, it will give us that digit. So if we were to look at our ones digit, it will return 0, 3, 2, 2, 1, 1, 0. And when this place increases to 1, we will have 10 to the 1 power. So that would be 10, and this would give us ones digit and 0 for the rest. And when we are looking at the hundreds digit, it will be 3 for this one. Okay, now we need to check if our current element is negative. If it's negative, what do we want to do? Well, we want to push that number into a negative bucket. Add bucket index and push current element. And else, if it's the other case, we want to push it to bucket index, push it to the bucket, and you forgot to put I here. Okay, that looks good. Let's just console log our bucket index, and you can see that for the first digit, we have 0, 3 for 3, 2 for 2, 2 for 2, 1, 1, 1, 1, 0, and 0. And when we're done with our ones digit, we are looking at the tens digit, and 1 is for this over here, and rest is 0. And finally, when we look at hundreds, we have our 3 here, which we have over here. That looks good. Our final step. What we need to do is we need to override our original input array every time we're done with each digit. So what we're going to do is set array equal to an empty array that concat, and we are going to spread all the values, and negatives has to come first because obviously negatives are lower or smaller than positives. Okay, we're almost done. And as you can see, we have our values, right? Well, you can see that our positives are all working correct. And this is obviously because it's going from smallest to biggest, right? But this one is using the same logic. It's thinking that these negative numbers are positives, and -1 is obviously bigger than -2, and -2 is bigger than obviously -310, right? So our negatives are in opposite or wrong order. So what we do is we just do dot reverse, and as you can see, we have our result. I actually made a mistake over here. It should be less than or equal to. Okay, now let's just uncomment our second example with 200 random elements, and you can see that everything's sorted well. So everything looks good, right? Now let's just uncomment this and just go through our code again. First thing is we want to find the maximum number of significant digits, and we did that over here. And place is going to track the current place that we are on, and we are incrementing our place before we use it. So this is going to evaluate to 0, and we're never going to use -1. We increment it here. So if you want, you can just get rid of this over here and then just do place increment here, but that's totally up to you, and I just want to leave it up here. Now we create our two buckets, negatives and positive, and remember that these look different, but it's essentially doing the same thing. Now we iterate through all the elements in our array, and we create our bucket index, and our bucket index is based on the current digit that the number is on. That's what it means to have a radix sort. We sort it by the current significant digits, or the digit of the current significant digits. So for the first iteration, 0, 3, 2, 2, etc., we go to our tens place, hundreds place, and so on and so forth. And we check if it's negative, we push it to the negative bucket. If it's positive, we push it to the positive bucket. So now we are actually done with putting all our elements into their respective buckets at the correct bucket index. And when we're done with that, we are going to overwrite our array with what we have so far in our negatives and positive bucket and overwrite that. And next, we have a new array, and we run this whole thing again on our tens digit. And we do that until the whole thing is sorted. And finally, we return our array. So that's it for our first solution. Our first solution is probably the easiest to code, easiest to understand. And I don't like the fact that I have to use reverse here because this is kind of expensive. And let's try to optimize this little by little as we go on. So that's it for our first solution. Now let's go over our solution. And for this one, we are going to handle negatives by sorting them later. What we'll do is, before we created two buckets to handle negatives and positives separately, but for this one, we're going to just create one bucket. And after we're done sorting, we are actually going to handle each and every negative numbers by taking them out from the array and then just unshifting or bringing them front of the array. And you'll see that clearly later when we actually do code. But before that, let's just go over our pseudocode really quick. Like before, everything is pretty much going to be the same. It's just that we're going to have just one bucket, and only major difference is actually step number 5. So when we're done with everything, we're going to iterate to all the items in the array and find negative numbers. And if it's negative, we're going to shift it to the front of the array. Now let's start coding. First thing I want is I want to get the maximum number of digits or significant digits in my array. And next thing I want to do is I want to create a variable called place and set this equal to -1. And this will be used to track the number of digits or significant place. Now I want to iterate as long as my place is less than my max value. So what we do is we increment place and then just run everything inside that loop. And later we just want to return our result. Okay, now let's create our bucket and I'll call it buckets. So this is going to be equal to array.from. We're going to pass in a length of Radix and we want to fill this up with empty arrays. Okay, that looks good. Next thing we want to do is we want to iterate through our array. Let's just use for each, and you can just use a typical for loop. It doesn't really matter. So current value, and now we need to get our bucket index. So that's going to be const bucket index, and we're going to round down, but this time we're going to take the absolute value of that current number and divide it by power of radix and place and mod radix. So this just gives us again the digit of the current place we're looking at. And now we want to put our current element to that index. So we're going to push it to our current value. And when we're done with this loop, we want to overwrite our array after we flatten out our buckets array. So flat. If I were to just console log my array, you can see that, or actually it's right here. You can see that everything is sorted, but it's kind of mixed up, right? But you can see that it's sorted based on the first digit. So zeros, ones, twos, and threes. Now we just need to be able to handle negatives. We want to go through our array, and then when we see a negative, we want to bring it forward. When we see another negative, we want to bring it forward, so on and so forth. Now let's just get rid of this and think about how we can do that. How can we bring this number? I guess we have to take it out from the array. We can't keep it, obviously. So take it out and then put it to the front of the number. So to do that, I'll just use unshift and splice. Now we want to iterate through our array, and let's just use for each again. And if my current value is less than 0, so if it's negative, what I want to do is, and I have to pass in an index here, I want to unshift. So what unshift does is it brings the element to the front of the array, and I want to splice a number starting at index I to just one element, and I want to return that first number. And if you look at our result, it looks good, right? But I just want to show you how this looks like, this whole thing. So this whole thing, let's just console log that. And as you can see, we are just taking this individual number out, unshifting this number to here, unshift -2 and unshift 310. And if I were to just get rid of this index of 0, we will return an array. So what unsplice does is it cuts that number out, stores it in an array, but we are not pushing an array into our result, right? We are pushing in that number. So we want to take that number out and then unshift. And if you delete that, we have our result. So let's finally check with our random numbers with 100 elements. And you can see that everything looks good, right? Yeah, so that's it for our second solution. So we were able to use one bucket to handle all the negatives and positives. But if you think about it, this whole operation is kind of expensive. We're iterating through the whole thing again, doing a lot of stuff. So we will try to code something better for our next solution, and let's get to the next solution. Now let's go over our third solution where we will be handling negatives, and we are going to handle negatives differently this time. We're not going to create two different buckets for positives and negatives. We are not going to use unshift and splice, which I really don't like to use because it's expensive. So we are going to handle our negatives, and this is our pseudocode for it. And I think this is actually going to be one of the shortest code for our solution. And the major only difference is where we create our index for this solution that we're going to implement. Other than that, I think pseudocode is pretty much the same. So give it a go. If you're stuck, just come back to it. Now let's code our solution. So first thing I want to get the maximum number of digits in my given input. And for our case is 3, 0, 1, 2, 3. And next I want to create my min value variable to store my min value. And that's it. Next, I need to declare a variable to track current significant digits. So let's just create a variable named place and set this equal to -1. Now we need to iterate until our place is less than our maximum digit count. So let's use a while loop, and the place increment, as long as this is less than our max value, we're going to run whatever is inside our function or our while loop. Next thing I want to do is I want to create a bucket to store all my numbers. So bucket is going to be array.from is going to have a length of radix, and we will fill this up with empty arrays. Okay, that looks good. Now let's iterate to all the elements in our array. So I'm going to use for each and pass in a current value and index. Now what we need to do is we need to find the index or the digit that we are going to look at. So if we are at the ones place, we obviously want to look at the ones digit only. When we are at the tens place, we want to look at this 1, hundreds 3. So how do we get that digit? So what we do is math.for. We're going to pass in current value minus min. So this is how we are going to handle negatives, and we divide that by the current digit place that we're looking at, and we mod by radix. And what we're going to do is we're going to push in that number at that digit, push current value. We actually don't need this index, so let's just get rid of it. All right, that looks good. So let's just console log index to just see what we get. And as you can see, these are the indexes that we're getting. You might have noticed that it's a little off. Well, when our number is 0 or 310, our index became 0. 3 is 3, 8 for -2. Where did that come from? Well, that's because we are handling our negatives here. So if I were to just console log my number, so current value, and also I'm going to console log minus min. You can see that our numbers are a little different. Well, it's because we're technically adding, our min is -310. So if you were to add -310 to 310, that would be 0. And if you were to add 310 to 3, it will be 313, 308, so on and so forth. So all the numbers actually kind of have a different digit ending. But this is how we are handling our negatives, just to know that. And we are pushing in that current number to that index that we are getting. So let me just get rid of this. So this is our code for pushing it into the correct index. And now what we want to do is, let's just first actually return our array. Now what we need to do is override array with elements in the bucket array. So since every time this is running, we are resending our buckets, but we want to save our result. And where do we save that? We are saving into our original input array. So now we want to override all the elements in our array with our somewhat sorted bucket. So what we do is buckets.flat, and this is going to flatten out all the elements that are in our buckets array. And as you can see, we have our final result here. And let's just uncomment this one just to make sure. We're going to have an array with 100 random elements that ranges from -100 to 100. So as you can see, everything sorted, bunch of duplicates, a lot of negatives and positives, and it looks good, right? And the first one passes. So let me just comment this out, and let's just go over the code just one more time. So we found our maximum number of significant digits. We got our minimum number. Here we declare place with -1. And the reason is because we are incrementing place here. And this -1 is going to be 0. And 0 is going to be replaced over here. And you actually don't have to do this. You can just get rid of this and then just increment place here. But I think just having it up there is more straightforward. So I'll just leave it here. And now we are creating our bucket with empty arrays and iterating through all the elements in our array. And we are getting our index for each digit or each number that we are looking at. And we are pushing in that number to that specific index that we got. And after we do all that for the all numbers in our array, we flatten out our bucket. And every time this whole thing runs, it's going to be sorted just a little bit. We're going to be sorting it digit by digit. And we overwrite that every time to our input array until we loop through the whole thing digit number of times, which is this outer loop. And finally, we return our array. So that's it for our third solution. I think this is probably the easiest code, and I think it looks kind of familiar to our previous code. It's actually the same, except that this part, and we didn't have shifting and splicing of our array. So this looks more cleaner. It's actually easier to code. And later, for our next solution, we're going to implement our Radix sort using counting sort. Now let's go over our last solution where we are going to implement Radix sort using counting sort. Counting sort is actually going to do all the heavy lifting for this solution. If you don't know what counting sort is or how it works, definitely watch the video that we went over before this, which is obviously counting sort. And try to at least watch the first part where we introduce counting sort and illustrate how it works step by step, and look at the last solution for counting sort. If you have the time, definitely do watch everything. Now, the pseudocode itself is actually exactly the same for counting sort, except two things. It's going to take two more parameters, which is going to be radix and place, which is going to be, of course, passed in from our radix sort function. Place is going to represent the current significant digit. Another thing that I want to point out is for our radix sort function, we want to iterate until max minus min divided by mat power. I forgot to write power here. Radix place is greater than or equal to 1. And since we are looking at powers of 10 or radix of 10, just think of this as 10, and place is going to obviously represent the exponent. So what we do here is we are iterating until as long as the range divided by this whole thing is greater than or equal to 1. Well, if you are pretty good with math, I think this is pretty straightforward to understand, but if not, that's totally fine. So what this means is that at first iteration, our place is going to be 0. And if our radix is 10, it means that this is going to evaluate to 1 because 10 to the 0th power is always 1. Our range is the range of numbers, right? So for example, if we were to look at our input array, our min is -310 and our max is 3. And our range is going to be 3 minus -310. If you have two negatives, that's obviously going to turn into a positive. So our range for this input is going to be 313. So 313 divided by 1, that's going to be 313, right? So that means that we are going to look at the ones digit. And when our place increases by 1, we are going to have 10 to the 1 power. So that's going to be 313 divided by 10, which is going to turn into 31.1. Then we are going to look at the tens digit. And next, when this evaluates to 100, that means that we are going to look at the, obviously, the hundreds place. And this is going to evaluate to 3.13. And finally, when this evaluates to 1000, we are going to have a decimal number, right? So 0.313. So that means that we want to stop because we went over this whole function, our significant digit number of times, which was 3. That's it for pretty much the pseudocode. If you know how counting sort works, I think everything should be easy. If you don't, go back to counting sort and kind of review how it works. Other than that, I think we can actually start coding now. Okay, so I have my function which takes in two parameters array, and I gave it a default value of 10 for my radix just because that's easier to work with. First thing I want to do is I want to create my counting sort function. This is going to take three parameters, array, radix, and place. Okay, that looks good. And I want to just leave my counting sort like that for now and finish up my radix sort. So for radix sort, I need to find the max and min because I want my range of numbers. So it's going to be math max, and we pass in our array. Now we want our min, and we want to create a variable for our place and set this equal to 0. Later, obviously, I want to return my array. So let's just leave it here. And now it's going to be our while loop. So while we know that we need to get our range, so max minus min, and we divided that by power to the radix and exponent of place. So as long as this is greater than 1, we want to keep looping. And later what we want to do is we want to increment our place by 1 each time because we want to move our ones digit to tens, hundreds, and so on and so forth. Every time we are going to call counting sort, passing in our array, our radix, and our place. Okay, that looks good. Now let's go back to our counting sort. So first thing we want to do for counting sort again is to find min. And it's going to be the same, math.min. And if you notice, we're finding a minimum 2 times, right? And you can actually kind of get rid of this by passing in a 4th parameter min here, and then passing in it over here, and just you don't have to do anything, you can just get rid of this side. But I just want to leave it like this for now. Now I need to make a variable to store all the counts of the numbers. So this is going to be array.from, and it's going to be initialized with zeros. Next, I need my output array. So output, and this is going to equal to array from initialized with zeros again, but this should have a different length. It should have the same length as our array, because it's not like we're gonna have less elements or more elements after we sort. And finally, I just want to return my array here. Okay, it looks good. Now is the most important part for our counting sort. We need to be able to get frequencies of each number, and by each number, I mean the digits. So in order to implement that, let's iterate through our array. We're going to use for each, pass in current value. And I actually think this is the hardest part of this whole problem, is to get the index. So how do we get the index? Well, it's going to be math.for. We pass in our current value, subtract min, and we use mod radix. And again, this is just getting the digit of the numbers that we are looking at. And we are handling negatives by subtracting min from our current value. So what do you want to do? You want to increase our counts array at index and increment by 1 each time. And this should be counts. So this function is again just getting the frequencies of the numbers that's getting passed in, and it's looking at the digits at first for the ones digit, and the next is going to be tens, and finally it's going to be the hundreds. Now we need to accumulate our frequencies, and if you remember, we reduced for that before. So counts reduce, and let's pass in our accumulator, current value, and index. So we're gonna look at our counts index or counts array. We're gonna add our previous number, I minus 1. And just important thing, if you remember, if you don't pass a initial value for reduce function, what that does is this whole thing is going to start at index of 1. It doesn't start at index of 0. That's a key thing that you have to remember when you use reduce. So here we're accumulating all the numbers in our array, or actually, we're accumulating the frequency of all the numbers in our counts array. Okay, now that looks good. And we need to iterate through our array starting from the last index. And why do we iterate from the last index? Well, it's because we want a stable sorting algorithm. And like before in our counting sort solution, I want to just use reduce right. Or you can just regular for loop starting at the last index. So accumulator and current value. And like before, I need to get my index. So this is going to look the same. Index is going to equal to math for handle negatives by subtracting min divided by the current digit place that we're looking at and mod radix, and this should be const. Okay, there is actually one important thing that you have to pass in, and for this one we want to pass in a initial value of null, because I just passed in null because we're not going to use this. But if we don't pass in null, what happens is it's not going to start at the last element, it's going to start at the element before last, so meaning second to last element. And let's just rename this to ACC for accumulator. Now we want to overwrite our numbers at our output array. So it's going to be output at counts, and we pass in our index. And remember to subtract by 1. This is really important. And the reason is because the numbers here is going to be 1 greater. So for our input array, we have 8 elements, right? So numbers here is going to be represented by 1 through 8. But if you were to look at in terms of indexes, it's going to be 0 through 7. So that's why we subtract 1. And if this kind of confuses you, again, I think you should definitely go back to counting sort. But we won't go over that here because that's kind of out of scope for our Radix sort. Now, what we want to do is we want to decrement the counts index by 1 each time because we want to be able to handle negatives. And we're almost there. Finally, we want to overwrite the elements at our original array. So I'm going to just use for each, passing current value at index, and overwrite current element with output at index I. And I forgot my arrow here. So this should be it. Let's check our solution. And as you can see, the first ones look good. Let's uncomment this. 100 elements with random numbers, -100 to +100. And as you can see, everything looks good. So this is it for Radix sort. Let me just comment this out just to go over it one more time. And I actually want to show you guys one thing. So let's just console log max minus min. This should be the number that we're getting. So this is the range. And let's console log the whole thing out. So max minus min divided by the power. Just get rid of this one, and we should have a comma here or period. And as you can see, our range at first is 331, and that's because this evaluates to 1. So that means that we are looking at the ones digit. And next, we increment our place by 2 or by 1. So this becomes 1. And if you were to evaluate this, it will become 10. And if you were to divide 10, our range will become 31.3, which is what we got. And next is going to be 100. And 313 divided by 100 is going to be 3.13. And when this evaluates to 1000, we stop because this whole equation is going to evaluate to a decimal. That means that we iterate through our significant digit number of times, which is 3. And as you can see, this whole function or this whole Radix sort ran only 3 times. Once on the ones digit, second on the tens digit, and lastly on the hundreds digit. So that's it for our Radix sort. So this is the outer loop. And let's just quickly go over our counting sort. Not so much in detail, but just the overall process. So what we do is we get our min, we get our counts and output array. We iterate through all the elements in our array because we want to get the frequency of each number. And here we accumulate or cumulatively add all the numbers in our counts array. Here we start from the last element in our array. And why was that? That's because we want a stable sorting algorithm, and we replace our output by the index number that we got from our counts index, and we subtract that by 1, override it with current value, and we decrement that number each time because we want to be able to handle negatives. And again, if this whole thing just confuses you, definitely go back to counting sort. And we can actually kind of shorten this code just a little bit. So what I can actually do is just get rid of this, and I can just decrement here and just get rid of this -1 or -1. So this is essentially doing the same thing. And as you can see, everything's just looking nice, everything's sorted. And if you were to just uncomment this, everything's sorted here too. But that's it for our solution. And obviously this was the final solution. And if you had to take away one thing or one solution from this whole video, it should be this last solution. And obviously this is the hardest of them all, but I think it illustrates Radix sort really well. And oftentimes Radix sort is actually implementing using counting sort. Now let's go over our time complexity. So this is time complexity using counting sort, and these are our complexities, and it looks confusing. But do know that O of n plus b comes from counting sort. So this is the exact same thing that we had for counting sort. So it's just that our radix sort is being multiplied by O of d. Before it was O of n plus k, where k represented the range of numbers. And it's the same for our counting sort. I just use b for base. I think that was a little easier to understand. And time complexity for all the cases are the same because we're doing, again, same operation over and over again, regardless how it's sorted. So O of D represents the number of digits. So when we had our array, 310 was the number with most digits, right? So that means that we ran our function 3 times. N is obviously the number of elements in our array, and our OB depends on the radix that we use. And we stuck with the decimal number system, so our range is going to be 0 through 10. And if we were to use, for example, binary, it's going to be 2, where it's zeros and ones only. Now, if you remember from our last solution, n plus b is, again, it represents the counting sort, right? And this counting sort was executed how many times? It executed the number of times, the digit number of times. And when we had our input of negative 310, the most significant digits is 3. So we ran our counting sort pretty much 3 times. That's why it's O of D times n plus b. And again, O of n plus b comes from counting sort. Now, as for our space complexity is going to be O of n plus b, which is exactly the same as our counting sort. And where it shouldn't be k, I changed this to b, where base represents the number of possible values. So for decimals, it will be 0 through 10 or 0 through 9. For binary, it will be 0 through 1. Radix sort will have a time complexity better than O of n log n. So compared to our comparison-based sorting algorithms, it's better. But if we were to use different radix like 32 bits or 64-bit numbers, then it will perform something close to O of n log time. But the downside is that our counting sort is going to take a lot of space. So you have to kind of make that trade-off. Is it speed or space? But do know that this whole operation, radix sort, is going to take a lot of space. And sometimes, I know that space is cheap, but if it takes too much, obviously it's not worth it, right? Maybe we can have some better sorting algorithms. So that's it for radix sort, and next we will go over bucket sort. If you guys find this helpful, make sure you guys like and subscribe. Thanks.